So today we're going to talk about finding percentiles and then finding cut scores, which are just the numbers at the bottom of the normal model, for things that are outside or in between of those 1, 2, and 3 standard deviations. Because those are not very exciting, and most of the time the questions you're answering are not about those. Okay? So last night on the homework you did the 3 questions in the beginning about the cattle, right? We're going to keep talking about the cattle so that everything's the same numbers and that we don't have to like change the model 15 times. Okay? So here is the model for the cattle, which you didn't have to make last night, but here it is. Okay? Notice that I labeled that it was weight. Okay? Now, it's asking here, it says, using the normal model, the mean was 1,152 and the standard deviation was 84. For weights of Angus steers and exercise 17, what percent of steers weigh? And it starts asking you questions that you can't answer from here. Like the first one says, what percent pretty much weigh over 1,250 pounds? Well, 1,250 is somewhere in here, right? And we're looking for the percent that fall above that. Well, now we can't use the percentages and things that we did yesterday. That's not going to work anymore, right? I can't like manipulate the percentages if I don't know what the percent is in there, okay? So we're going to have to use your calculator. Now, this is all based on z-score. So before we do anything, we're going to find the z-score for a steer that's 1,250 pounds, okay? So z-score, 1,250 minus 1,152 divided by 84. So 1.16 repeated. Your calculator can figure out these percentages based on the standard normal model, which is where the mean is 0 and the standard deviations are 1. That's why we need the z-score first. Okay, now I'm going to show you where we're going to go in your calculator, and we're going to go there a million times today. All right, it's all on the note sheet if you need to go back and look at it later. But you need to go to second variables or second vars, which is right next to the clear button. Second vars is the distribution menu. After Christmas, we'll be using this menu all of the time. All of the time. So today we're just talking about normal curves, but all these other things where it says like t and chi-square and binomial and geometric, we'll be using all of those things. Okay? So we're just using normal things today. So the first 3 in that menu are normal situations. The first one, normal PDF, you will never use in this class. Okay? You're not going to use it. Do you know what it does? This is what it does. That's what it does. It is gorgeous, but it doesn't help you with anything. Okay? So we are not going to be using normal PDF. So we'll be using normal CDF and inverse norm. Okay? Listen very carefully to the difference so you don't get confused in your homework. Normal CDF stands for normal cumulative density function. That means it's calculating the cumulative percentage or the cumulative amount underneath the curve. So in this case, for like this problem, we want to know the percent of the time that something falls within 2 boundaries here, right underneath this curve. That's what normal CDF is used for. It's used to find percentages. If you want to write that down somewhere, you can. But normal CDF is used to find percentages. Inverse norm is the opposite, and we'll do that in a second. Inverse norm gives you a percentage, and it wants to know like the number that corresponds with that percentage. Okay? So inverse norm gives you a percentage, an original question, and you find the actual cut score. So normal CDF finds percentages, inverse norm finds cut scores, or cut points. Okay? All right. So right now we're using normal CDF because we want to find the area under the curve. If you have an 83, that's fine. You're just not going to see the same menu that I see. Okay? And I'll let you know what's going on in a second. So click on normal CDF. There we go. Okay. Normal CDF. And you'll see where it says lower and upper, and then some stuff we haven't talked about yet. So you have to give your boundaries for what you want the area under the curve for. So if you're looking at this picture right here, we want to know the percent of the time that the steer weigh above 1,250 pounds, right? So my lower boundary is this z-score I came up with for 1,250 pounds. That's the lowest part, right? So that's going to be 1.16 repeating. Yeah? And I'm going to, the question just asks what percent weighs over that amount. So we're going all the way out, right? Now, obviously, we don't know what the maximum steer will weigh. Like, we don't know the maximum value. We don't want to put a constraint on that because we don't know it. So we always say that if it's going in one direction or the other, we say that it's going to infinity, okay? Obviously, a steer cannot weigh infinity pounds. I get it. But we're just going to say it goes to infinity so we get all the possible area under the curve, and we don't like cut it off by accident, okay? If you're going the other direction, you go to negative infinity. You can't type infinity into your calculator. Great for you. We can't type infinity into our calculator, so we just use a very, very large number if it's positive and a very, very small number if it's negative. So we accomplish that by putting in a bunch of 9s. All right? I'm not even kidding. That's what we do. That shows, oh, look, we have this huge number. Again, that's quote-unquote infinity. Okay? Then we'll hit paste. And you can hit enter. Now, if you have a 83, when you click normal CDF, it just popped up on the screen with a parentheses, right? You just do the lower bound, comma, the upper bound, and hit enter. Okay? Did everyone, if you did this with me, get 12.2%? Yeah? Now, of course, I didn't put in like 1.6 repeating all the way. I put some 6s. So depending on how many 6s you put in will depend on how close you are to that. But you should have 12-something%. Yeah? Okay. So that would be the answer. 12.2% of the steer weigh over 1,250 pounds. Questions about that? About how I did that? About what I did? Okay. Let's do the next one. On the next one, we're looking to see what percent of the steer weigh under 1,200 pounds. So what percent weigh under, oh, that's not even 1,200. Didn't even get there yet. 1,200 pounds. So we want this area, right? So in this case, we'll be going from negative infinity to whatever our z-score is for 1,200 pounds, right? So our lower boundary will be negative infinity, and our upper boundary will be our z-score. So we need to find the z-score first. So 1,200 minus 1,152 divided by 84. So 0.5714, if you will. Yeah? So now we can use normal CDF to find the percentage. So our lower boundary is negative infinity, so I'll put in a negative and a bunch of 9s. And then our upper boundary is 0.5714. Then you probably put it in y equals by accident. You should be on the original screen. Remember when you dropped your calculator 5 seconds ago? All right, so in this case, I got 71.6%. Did anyone not get 71.6%? Are you putting in the boundaries correctly? No. Negative infinity, so a very, very large negative number, not a very, very small negative number. No, because that could be a z-score. That's a realistic z-score. Right? Negative 3, right? Negative 3 z-score is 3 standard deviations below the mean, right? So when you put a negative 0.01, you're within 3 standard deviations. Okay? All right. Anyone not get 71.6%? Okay, we good? All right, I want you to do the last one on your own. This time you have two boundaries. You have a lower boundary and an upper boundary. You should find the z-scores for both first. All right, here's what I got. Here's the z-scores. Here's your percentage. You don't know what? Mm-hmm. The lower one's the lower one. So 1,000 is lower than 1,100. So the z-score, negative 1.81, is going to be the lower bound. And the upper bound is going to be negative 0.619 because that's the upper pounds. So you went from the smallest to the largest. Mm-hmm. This. Questions on that one? All right, any questions about normal CDF? All right, so the first part of your assignment tonight, you'll have to do this. Okay? Now, there's the opposite. We haven't used inverse norm yet. So we're going to do the opposite. So, the opposite, what if I want to know the bottom 90% or the 35th percentile or the top 10%? All right? If I want to know the value that goes along with that, then I have to use a different function in my calculator. I'm actually going to be given a percentage in the problem, so it won't help to find a percentage as the answer like we've been doing, right? We're going to go backwards. So, still the cattle, still the same numbers, still the same model. It says, what are the cutoff values for? And you have the highest 10%, the lowest 20%, and the middle 40%. So I'm getting some percentages. Listen very carefully to how this works, because it only works one way. Your calculator calculates the percentages from the far left to the right. And that's the only way it calculates these percentages. So when I say that, the first question says, we want to know the cutoff value for the highest 10% of weight. So the highest 10% is going to be somewhere over here. Right? Highest 10%. We need to know this value that goes with that. Problem is, like I just said, your calculator calculates from the far left to the right. So I can't just type in 10% into my calculator and get the correct answer. That will not work. That will give you the lowest 10%. So you have to use 90% because you have to calculate from left to right. Okay? It's not that that's like a hard concept, just you have to remember that your calculator cannot be as smart as you. Okay? So if you put in 10%, you will get the lowest 10% instead of the highest 10%, which you don't want. So you want the lowest 90%. It's the same as the highest 10, right? So in your calculator, go back to the distribution menu. Underneath normal CDF is inverse norm. Hit enter. It only asks for one thing here. It asks for the area. The area is the percentage in decimal form. All right? So we want the lowest 90%, so we type in 0.9. And we hit paste. This gives you the z-score. All right? So that z-score is 1.28. I want to know the cutoff value in weight for the cattle, right? But so now I can just work the z-score formula backwards to get back to the pounds, right? So 1.28 equals how much the steer weighs, minus 1,152 divided by 84. So to solve this, I multiply by 84 and add 1,152. So we can round it to be exact. Here, I'm not looking for the exact answer since we're just looking for the steer weight. So you can say 1,260, and I'm fine with that. All right? So the top 10% of weights, right, is from 1,260 pounds and above. Does that make sense? Yes? Maybe? On the second one, the lowest 20%, that one's easy. We don't think backwards. Lowest 20% is just the first 20%, right? So we just go back into the same thing, but we do the lowest 20, so 0.2, always in decimal form. So I get a z-score of negative 0.842 this time. So you multiply by 84 and add 1,152. The lowest 20% of the steer all weigh less than 1,081 pounds. Does that make sense? Where I'm getting that? Now, the last one, the middle 40%. You should think about this. All right. If we want the middle 40%, that means we want from like here to here. Right, middle 40. That means I need to know the percentages for each half of this, right? So if you have the middle 40, what percent is left over from 100? 60. It means there's 30% on each side, right? So this number will be the lowest 30%, right? This would be the top 30%, which would also be the lowest 70%, okay? Just think about, if you want the very middle 40, you have to subtract and divide by 2, okay? So we're going to find the 30th percentile and the 70th percentile and go from there. I'm not going to do this one because we just did it 2 other times. Just think about what you to get those numbers. So in this case, we're going to get a range of values. We're going to say like an interval. We're going to say from this many pounds to this many pounds. It's not going to be one number. Does that make sense? Okay. On this last one, just so you know the vocabulary, when it's asking for percentiles, percentiles always measure from left to right, so they're straightforward. So when it says 40th percentile, you're looking for the lowest 40%. When it says 99th percentile, you're looking for the lowest 99%. Okay, so you don't have to go backwards or anything. It's just different language. What's the point of wanting to know 99%? You want to know the cutoff value. So maybe you want to know like how smart the top 1% are. Well, that's the 99th percentile. It's just different language. And then the last one is IQR. Now, IQR, you have to answer this question multiple times tonight. IQR is Q3 minus Q1, right? Well, we need to know the percentiles to do that. So Q1 is what percentile? Q1 is the first what percent? 25. So this is the 25th percentile. Q3 is what percent? 75th. But then to find the IQR, once you go back and actually find the pounds, in this case, you're going to have to subtract them and give me one value, because that's what the IQR is, right? So you can't say the IQR is from this many pounds to this many pounds, because that's not the IQR, right? The IQR is one number. So on the middle 40%, you're going to say it's from this many pounds, whatever. But then on IQR, that's a specific thing in statistics. You have to actually subtract them at the end.
So, but that's not inverse. That's the other.
That would still be inverse.
No, because that's only the percentile.
Yes, we are. We're finding the 25th percentile and the 75th percentile.
How is it one inverse?
You have to subtract them. How do you find the IQR? Oh, so we're going to use the percentiles to find Q3 and Q1.
But that's not what IQR is.
Yes, it is.
Doesn't sound like it.
It's exactly what it is. Yes. All right, here's the assignment. And then I'll help any of you that are still struggling. On page 132, you're going to do number 38 to 42 even, and 43 and 44.
43 and
44. That.